Hello, my name is Kepsi and welcome to my YouTube channel. Today our discussion on ordinary differential equation will be on solution to higher order ordinary differential equation, the continuation for that matter. Remember, we say higher order ordinary differential equations take this form. Thus, they are differential equations that are more than order 1, order 2, 3 in that order. So, and also recollect that we say higher order ordinary differential equations are of two forms. They are either homogeneous or non-homogeneous. And we said that their homogeneity is determined with the g of t. Then it is homogeneous. If it is not equal to 0, then it is not homogeneous. That's when g of t, that this side is equal to 0, is homogeneous. And when g of t is not equal to 0, that it has a function, then it is non-homogeneous. Please, did you watch my videos covering the homogeneous one? If no, stop this video, go back, check that video before you come, because our idea in the homogeneity or the homogeneous one will play a very important role today. So, we learned that the non-homogeneous ordinary differential equation or differential equation, if with the g of t in this case is equal to 0. When we meet a non-homogeneous higher order ordinary differential equations, 3 methods comes to mind in solving them. What are these methods? Among these methods, we'll be taking one. Then we'll know what it is and we'll solve some sample problem using that method. So the 3 methods that comes into mind when we are solving our non-homogeneous higher order ordinary differential equations are the method of undetermined coefficients, the method of variation of parameters, then the D operator method. Today in this video, all the problems we'll be solving will apply the method of undetermined coefficient. So what do we mean by method of undetermined coefficient? Then we'll solve some sample problems using the method of undetermined coefficient. So come along. So with the method of undetermined coefficient, we'll split our non-homogeneous higher order ordinary differential equation into two parts. That's the homogeneous part, and we solve the non-homogeneous in the other side. So that means that we imply the Q of, we suggest that our Q of t is 0. Immediately 0, it becomes homogeneous. Then we'll solve that homogeneous side. Then we'll find a solution to the non-homogeneous aspect, that's the Q of t. Then after that, we join the two using the principle of superposition. The principle of superposition. So we said that our solution to the non-homogeneous higher order ordinary differential equation using the method of undetermined coefficient will be equal to y of c plus y of p. Thus, y of c is the complementary solution to the homogeneous side, and y of p is the solution to the non-homogeneous side. After we do that, we combine the two using the principle of superposition. So now we take some sample questions and see how we solve non-homogeneous higher order ordinary differential equation using the method of undetermined coefficients. So let's solve our first problem. They say solve the differential equation y prime prime minus 5y prime plus 6y equal to 2x plus 3. So how do we solve this? Please remember, we said that with the method of undetermined coefficient, we solve a homogeneous side by equating this to 0. Then after that, we take the second side. So we say that y prime prime minus 5y prime plus 6y should be equal to 0. Immediately we equate it to 0, it becomes homogeneous. And remember, when we are solving homogeneous higher order ordinary differential equation, 3 conditions counts. When the root from the equation is either 2 distinct roots, 2 repeated roots, or complex root. Please check out that video because it will help you a lot on YouTube. So now, we say with that, we let our y to be equal to e of r of x. Then we differentiate this function with respect to y. So y prime will be equal to r e of r of x, and y prime prime will be equal to r square e of r of x. After that, we substitute back. Our y prime prime is r square e exponent r of x minus 5 r e exponent r of x plus 6 e exponent r of x equal to 0. What is common? E exponent r of x is common, so we have r square minus 5r plus 6 e exponent r of x equal to 0. So divide both sides by e exponent r of x, then we can get r squared minus 5r plus 6b equal to 0 since we divide. Now we solve this. When we get the root from this equation, we know the type of the non-homogeneous higher order ordinary differential equation. So r squared, remember how to solve this? Get minus 3r minus 2r plus 6 equal to 0. This is a quadratic equation. What is common? R is common. R minus 3. Minus 2 is common. R minus 3. R minus 3 out. R minus 2 equal to 0. So R is equal to 3 or 2. So these are two different or two distinct roots. Then our complementary solution will be equal to A E exponent, the first root, that's 3x, plus B E exponent 2x. So we have found solution to the non-homogeneous side. To the homogeneous side, we take the non-homogeneous. So the type of the function of G which makes it non-homogeneous will determine how to solve it. So since this is a linear function that it doesn't involve any quadratic term, we let the coefficients which we are determining be linear. That's how the method came about, methods of undetermined coefficients. So we said that we let our y of p, which is the solution to the non-homogeneous side, be equal to maybe mx plus c, or you can use bx plus a in it, or ax plus b. It should just be linear, looking like this. So what do? We differentiate this function into the order of this differential equation. So we find y prime of p. So y prime of p, we differentiate this function with respect to x. So we have m. This is constant. Then we find y prime prime of p. This is constant. When we differentiate, that becomes 0. What next? We substitute this into our original differential equation. That's y prime prime minus 5y prime plus 6y equal to 2x plus 3. Then we'll be able to determine the coefficients and the constants. So we have, what is our y prime prime? That's 0. So 0 minus 5. What's our y prime? That's m plus 6. And our y is the initial, which is mx plus c, equal to 2x plus 3. So now we solve 0 minus 5x, that will be minus 5m, then this will be 6mx plus 6c equal to 2x plus 3. So now we'll group them very well. We have 6mx plus 6c minus 5m equal to 2x plus 3. This means that the coefficient of this x here will be equal to the coefficient of the x here. And anything constant will be equal to the constant. This implies that our 6m, which is the coefficient of the x here, will be equal to 2. So equal to 2. Our m in that case will be 2 over 6, and m will be equal to 1/3. Then also, our 6c minus 5m will be equal to 3. That's 3. Now, we know m. So we say 6c minus 5 times 1/3 will be equal to 3. 6c will be equal minus 5 over 3 is equal to 3. 6c will be equal to 3 plus 5 over 3. 6c will be equal to, this is over 1, all over 3. 1 will go into 3 once, times 3 will be 9, then plus 5. 6c will be equal to 14 over, so c will be equal to 14 over 3 times 1 over 6. I hope you understand that. So this will be, that will be divided by 6, so divided by 6. So I have 14 over 3 times 1 over 6, so that you get it all. So our C then will be equal to 14 over 18. 2 into 14, 7. 2 into 18, 9. So our C is equal to 7 over 9. So M is 1/3 and C is equal to 7 over 9. Then we can say, look at that, we say our Y of P should be equal to mx plus c. Then our Y of P will be equal to 1/3 x plus 7 over 9. So we find the solution to the homogeneous side we had this, and not the homogeneous side, non-homogeneous side we had. And then we can say, with the method of undetermined coefficients, our y, let's say our y of x, which is the solution to the higher order ordinary differential equation, will be equal to a e exponent 3x plus b e exponent 2x, then plus 1/3 x plus 7 over 9. I hope you get that. This is a general solution. If some boundary conditions are given, we substitute to form a particular solution. I hope you get that. We'll solve some more. So we said the example 2, solve the differential equation y prime prime minus 5y prime plus 6y equal to 12 e exponent 5t. So how do we solve this? So remember, using the method of undetermined coefficient, our y will be equal to the complementary solution for the homogeneous side and the solution for the non-homogeneous side. So what is the homogeneous side? Our y prime prime minus 5y prime plus 6y should be equal to 0. That makes it homogeneous. So we let y to be equal to e exponent r of t in this case. So our y prime will be equal to r e exponent r of t, the differential of this function. Then y prime prime will be equal to r squared e exponent r of t. However, we substitute this into this. So we have r squared e exponent r of t minus 5 minus 5r e exponent r of t plus 6 e exponent r of t equal to 0. What's common? E exponent r of t is common, we bring it out. So we have r squared minus 5r plus 6 e exponent r of t equal to 0. When we divide both sides by e exponent r of t, we get r squared minus 5r plus 6 equal to 0. And when we solve this quadratic equation, our r will be equal to 3 or 2. Now, our complementary solution, since we have two distinct roots, will be a e exponent 3t plus b e exponent 2t. I hope you get that. Now, this is the solution to the homogeneous side. Now, we find the solution to the non-homogeneous side. That's the y of p. So, since we have this thing be equal to 12 e exponent 5t, we want to determine the coefficient there. So, we said that we let our y of p to be equal to c e exponent, that's e exponent 5t. So now if we differentiate this, we find y prime of p equal to 5c e exponent 5t. Then our y prime prime of p will be equal to 25c e exponent 5t. What do? We substitute into our problem y prime 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 minus 5y prime plus 6y equal to 12 e exponent 5t. So when we substitute our y prime prime prime, which is this, will be 25 c e exponent 5t, then minus 5 bracket y prime is 5c e exponent 5t, then plus 6, and what's our y? That will be c e exponent 5t should be equal to 12 e exponent 5t. What happened? We get 25c e exponent 5t. 5 times 5, that will be 25, so we'll get minus 25c e exponent 5t again, then plus cc e exponent 5t equal to 12 e exponent 5t. So this minus this is 0. Since they are the same, we then have cc e exponent 5t, 12 e exponent 5t. Look at that, we have e exponent 5t will equal to the coefficient 2. You divide both sides by c, our c there will be equal to 2. Now, we're able to find c, so we substitute it here. Then we can say our y of p will be equal to 2 e exponent 5t. So when we find the solution to the non-homogeneous side, we had this. Then the homogeneous side, we had that. And we said that with the method of undetermined coefficient, our general solution y will be equal to the complementary solution to the homogeneous side plus the solution to the non-homogeneous side. So y will be equal to, this is a e exponent 3t plus b e exponent 2t, then plus this, which is 2 e exponent 5t. Then we said this is the general solution to our non-homogeneous higher order ordinary differential equations. So let's solve our third question. They say solve the differential equation y prime prime minus 4y prime plus 4y equal to 2 e exponent 2t. So how do we solve this? Again, we say using the method of undetermined coefficient, our general solution will be equal to the solution to the homogeneous aspect of it plus the non-homogeneous. Very, very important. So it becomes homogeneous if y prime prime minus 4y prime plus 4y is actually 0. What do? We let y to be equal to e exponent r of t. Then we find our y prime, it will be r e exponent r of t, then y prime prime will be equal to r squared e exponent r of t. We substitute back. So we get r squared e exponent r of t minus 4r e exponent r of t plus 4 e exponent r of t is equal to 0. What is common? E exponent r of t is common. I'll factor it out. E exponent r of t equal to 0. When I divide both sides by e exponent r of t, I will just have a quadratic equation which is equal to 0. Now how do we solve this? So this, that will be 2r minus 2r plus 4 equal to 0. Factors of 4, when we add we get negative 4, we multiply we get 4. So when we bracket this, what is common here? R is common, r minus 2. 2 is common here, minus 2, r minus 2 equal to 0. We have r minus 2 out, r minus 2 equal to 0. So our r will be equal to 2 repeated. So we have a repeated row. Remember, when a solution to our quadratic equation from the homogeneous higher order ordinary differential equation is a repeated row, how do we write the general solution? So our complementary solution, y of c will be equal to a e exponent 2t. Remember, the r is t. Then plus bt, if you remember very well, e exponent 2t. So that will be the solution to the homogeneous side. Now we find the non-homogeneous. So we let our y of p to be equal to, look at this, it's also carrying the power 2t. This implies that our next term should have t squared. Very, very important. So we let y of p to be equal to c t square e exponent 2t. Very, very important. So now we differentiate this. Remember, see, t square is multiplying e exponent 2t. That will be two different functions multiplying each other. We use product rule. So our y prime of p will be equal to, what do? We differentiate t square. We'll get 2ct e exponent 2t, then plus. So we differentiated t squared and we keep e exponent 2t. Now we differentiate e exponent 2t and keep t squared. We'll get 2c t squared e exponent 2t. What do? We find our y prime of p. Our y prime of p, we keep the 2t here. Or we differentiate 2t first, we get 2c e exponent 2t. This is also product rule, remember that. Then plus, now I'll keep my 2ct and differentiate e exponent 2t. I'll get 4ct e exponent 2t. Very, very important. Then plus, here, I'll differentiate t square, I'll get 4ct e exponent 2t. Then plus, now I'll keep my t square and differentiate this. I'll get 4c t squared e exponent 2t. After the differentiation, we substitute it into our differential equation or into our problem again. So our y prime is this. That will be 2c e exponent 2t plus 4ct e exponent 2t plus 4ct, or when we have 4ct plus 4ct, that will give us 8ct. So let's just write it at once. So we have 2c e exponent 2t plus 8ct e exponent 2t, then plus 4ct squared e exponent 2t. That's for the prime, the y prime. Then minus 4 bracket. Our y prime is this. That's 2ct e exponent 2t plus 2ct squared e exponent 2t. Then plus, plus 4c and 4y. And what's our y? Is the ct squared e exponent 2t. So now we expand this bracket. So we have 2c e exponent 2t plus 8ct e exponent 2t, then plus 4ct squared e exponent 2t. This times this will be minus 8ct e exponent 2t. This times this will be minus 8ct squared e exponent 2t plus 4ct squared e exponent 2t. And remember, it will be equal to 2 e exponent 2t. So now we group like terms. The t squares will come first. So we have minus 8ct squared, then plus 4ct squared plus 4ct squared. So I did not bring the e exponent 2t. So e exponent 2t plus 4ct squared e exponent 2t, then plus this 4ct squared e exponent 2t. Then I'll bring the linear term. So I have 8ct e exponent 2t, then minus 8ct e exponent 2t, then my constant 2c e exponent 2t equal to 2 e exponent 2t. So look at it. Minus ct squared plus 4ct squared will give us negative 4ct squared plus 4ct squared will be 0. So the whole of this is 0. 8ct e exponent 2t minus 8ct e exponent 2t is also 0. So we'll be left with just 2c e exponent 2t equal to 2 e exponent 2t. since we have e exponent 2t at both sides, imply that 2c is equal to 2. So our c is just 1. Then we can say that our solution to the non-homogeneous side, which we said should be ct squared e exponent 2t. C is 1, therefore y of p will just be equal to t squared e exponent 2t. Then our solution to the non-homogeneous higher order ordinary differential equation y will be equal to the homogeneous side, which is a e exponent 2t, so a e exponent 2t plus bt e exponent 2t, then plus t squared e exponent 2t. I hope you get that. This is very, very simple, though lengthy. So now we'll solve our last question on this, then we'll call it a day. So we'll solve our last question on this. Before we do that, please remember to subscribe to my YouTube channel if you are here to like, share, and comment. Your comment keep me going. So they say solve the differential equation y prime prime plus 9y equal to 2x squared minus 5. So this is non-homogeneous. No one should tell you that, since our g of x is not equal to 0. So remember, using the method of undetermined coefficient, the general solution y will be equal to the solution to the homogeneous side plus the solution to the non-homogeneous side. Very, very important. So the homogeneous side, we say the y prime prime plus 9y, if it is equal to 0, that means it's homogeneous. What do? We let y to be equal to e exponent r of x. Remember that. So our y prime will be equal to r e exponent r of x. Then our y prime prime will be equal to r squared e exponent r of x. What happened? We substitute. So in place of y prime prime, we have r squared e exponent r of x plus 9 e exponent r of x equal to 0. What is common? E exponent r of x is common. So we have r squared plus 9 e exponent r of x equal to 0. When we divide both sides, we have r squared plus 9 equal to 0. Our r squared will be equal to negative 9. R will be equal to the square root of negative 9. So r will be equal to plus or minus 3i. I hope you know that. So this is a complex root system. And remember, when we are faced with a complex root system, when solving homogeneous higher order ordinary differential equation, our complementary solution y of c will be equal to e exponent r of x bracket a sine beta x plus b cos beta x. What is our r here? The r is the real part of our complex solution, and the real part here is 0. Since it is 0, e exponent 0 will be 1. So this place will be 1. Then our beta is the coefficient of the imaginary part, in this case 3. So our complementary solution y of c will just be a sine, the beta is 3, so 3x plus b cos 3x. That's the solution to the homogeneous side. Now the non-homogeneous side. Look at that side, 2x squared minus 5. This is a quadratic equation. So we must let y of p, okay, be equal to a quadratic expression. Say ax squared plus bx plus c. What do? We find y prime of p. So we are going to differentiate this function with respect to x. What we get? We'll get 2ax plus b. Then we'll find the second differential, y prime prime of p to be equal to, this will be 2a. Remember, this is constant, it will be 0. What next? We substitute this into our problem. So we substitute. Our y prime prime is 2. So 2a plus 9. What's our y? Our y is ax squared plus bs plus c, and that will be equal to 2x squared minus 5. When we expand that, we get 2a plus 9ax squared plus 9bx plus 9c equal to 2x squared minus 5. Now we arrange, we get ax squared plus bx plus 9bx, then plus 2a plus 9c equal to 2x squared. Method of undetermined coefficient. We equate coefficient. So the coefficient of the square terms, our 9a will be equal to 2. A will just be equal to 2 over 9. Remember, our 9b, we don't have x10, that means it's 0. Therefore, b is equal to 0. Then we can say 2a plus 9c is equal to negative 5. What is a? Remember, a is 2 over 9 plus 9c equal to negative 5. We have 4 over 9 plus 9c equal to negative 5. So we can say 9c equal to negative 5 minus 4 over 9. 9c will be equal to, the LCM here is 1. The denominator there is 1. LCM 9. 1 will go there 9. 9 times 5 will be 45 minus 4. 9 will go there 1 times that. So 9c will be equal to negative 49 over 9. Then c will be equal to negative 49 over 9 divided by 9. So c will be equal to negative 49 over 9 times 1 over 9. This will be equal to negative 49 over 81. Then we can say that our complementary solution, the solution to the non-homogeneous side is equal to, remember we said it should be ax squared plus bs plus c.